A very good morning to all. So today we will see once again the case studies, and then once again I will repeat about the types of requirement. So as per the video, I have told you the insulin pump control system. How does it works? Okay. So after seeing that video, you might have got an idea that how exactly that insulin blood pump control system works. Okay. So these are the four basic activities, okay, on which, or you can say that these are the four basic needs, right? Or these are the four basic requirements depending on which your entire pump control system is going to work. So here we can see that it collects the data from blood sugar sensor. There is a sensor, okay, and from where the blood is collected and then it is tested. And depending on that, it will calculate the amount of insulin that is being required to be injected to the patient. So we need the blood sugar and we need to test the blood, and depending on that, the blood sugar level is calculated, right? So depending upon the rate of change of blood sugar level, there is a calculation which is needed to be made for blood sugar levels. After taking that blood sample, different calculations must be performed. And depending upon that calculation, the signal should be sent to the micro pump in order to provide dose of insulin to the patient. So we take input as a blood here, then it is tested by the blood sugar sensor, and then the calculation of amount of insulin that has to be provided is done, and depending on that, the micro pump is going to pump or going to generate that much amount of, only that much amount of insulin, and then that is given to the patient. We have to also take care that low amount of insulin may cause to brain malfunctioning, or it may cause sometimes the death of a patient. Whereas high amount, if we give high amount of sugar, it may damage the kidney as well as eye. So these are the basic requirements which are needed to be implemented. So these are the user requirements, the requirements which are being provided by the user. Then how you are going to write the code for these requirements is called as the system requirement. How you are going to frame the code for all these requirements, that will become your system requirement. So these are the requirements which user needs from your software, and system requirements will be what type of code you are going to write to satisfy these requirements. So those requirements are called as system requirements. Now let us see about the architecture, right? So in this you can see that this is the architecture or overall diagram which will represent the working of insulin pump control system. So here you can see that if you try to remember that diagram, there is a main display, okay, on the inside that display one controller is there. So what is that controller going to do? That controller is going to read the values. So that controller is going to work depending upon two inputs, okay. What are the two inputs? Who will tell? What are the two inputs needed to for this insulin pump control system? What are the two inputs that are needed?
Blood test.
Yes, Ketan. First thing is that we need the blood sugar level, isn't it? We need to test the blood. So depending on that, yes, depending on that, see here, this sensor, okay. So here the blood sugar level is tested. So after sensing that blood sugar, what that controller will do, it will take that value, right? And then you can also set using display 1 or display 2. You can also set the value, and while setting that value, that is displayed on the screen, okay? Or your blood sugar level is also displayed on the screen. So on the screen, you can see your blood sugar levels, and you can also set what amount of insulin has to be given to the patient. So once when you set that in the controller, what this pump is going to do, okay, that pump, okay, is going to provide that insulin, Okay, pump, it is going to provide the insulin with the help of needle to the patient, right? So everything is controlled by the controller here. The controller plays major role in this. Okay, there is a microcontroller which is installed inside that hardware. Okay, or you saw that system, inside that microcontroller is installed, and that microcontroller will take two inputs. One is the blood sugar level and second is the timing. Okay, so the user has to set the timings, how many times you have to provide the insulin or how many times the insulin has to be provided to the patient. So there is alarm also, there is a beeping also at the time of providing the insulin to the patient. So this is automated. Sometimes manually patients are provided with the injections, but this is a automated software. All right, so this is all about the architecture of insulin control system, right? So this diagram is called as activity diagram. Okay, so these type of diagrams are used in designing. When a software developer is developing the softwares, after collection of requirements, there is a designing part. So designing will help us to know the flow of data. Designing will help us to know how does the data flows from one activity to another activity or from one process to another process. So this is the architecture and this is the activity diagram. So in this activity diagram, see how does it works. So the blood sugar levels are calculated by the blood sensor. Okay, after that it will analyze the sensor reading. It will compare the old readings of a patient and the recent readings of a patient. Okay, so it will maintain some backup also where it will make a record of, or it will maintain the readings, okay, of the blood sugar level of the patient, and depending on that it will make some analysis, or it may, depending on that, it will calculate how much amount of insulin is needed to give today to our patient. Then it will calculate the blood sugar levels also. Okay, it will that sensor, okay, it will compare the readings and then it will finally calculate how much amount of blood sugar level is there in our patient today. Okay, and then depending on that it has to calculate the amount of insulin that has to be given to the patient, right? Then so at the time of giving the insulin dose, at the time of giving the insulin dose, okay, so it has to set the pump. Depending upon the amount of dose, some data is provided to this pump, because that data is very, very important. As I told you, it should not have low sugar levels or high sugar levels. Calculation plays very, very major role here. So otherwise it may have a great impact on the health of patients. So this module, or you can say that this phase is very, very important, because the calculation plays very important role here. If it is calculated correctly, then we can provide assurance that our system is also working correctly and there are no harm to our patient, right? Then it may repeat the cycle. Okay, it may repeat the cycle. See, sometimes the blood sugar level may change continuously. At that time this activity is repeated, these activities are repeated. Okay, so log dose, insulin log. Suppose sometimes insulin is needed 2 times, or someday the insulin may be needed 3 times. So that is why these activities are repeated. Log in and log out activities are repeated. This is almost you can say that setting or resetting of your pump, okay, depending on the blood sugar levels. Now once after finalizing that blood pump, okay, insulin dose, what happens, that compute pump command. So that level is calculated and commands are given to your pump, and depending on that what the pump will do, it will provide, okay, it will provide the insulin. That insulin is injected or given to the patient. All right, so these type of diagrams are called as activity diagrams. Okay, so they may ask you in exam to draw any of the activity diagram. They may ask you this diagram also, that is draw the activity model of insulin pump. They may ask this diagram also. It is very easy to remember. You have to just to show what activities are carried out and what are the process involved in the activities. Okay, so the square boxes, and you can see that there is a round cornered rectangle boxes. Okay, so you can say that the blood sensor, okay, or blood sugar, insulin log or pump data or insulin pump. What are these? These are the main components of the system, and these are the processes. Okay, what are there in the rectangle, rounded rectangles? These are the processes. And blood sensor, blood sugar, what are these? These are nothing but the components of the software, and the arrow indicates the flow of data. So depending on the depending on these requirements given or provided by the patient, or if the doctor is providing you these requirements, so we came to know that in order to satisfy those user requirements, you have to build a very proper code, and you have to build the code in such a way that it is going to work perfectly. So that code is nothing but the system requirement. Collecting the problem or the user problem is called as a user requirement, and writing or solving that user requirement is the system requirement, means writing the code in short. Deciding the architecture, finalizing the hardware and software requirements, all these comes under the system requirements. That is in more detailed way. That is nothing but designing, coding, all these things. Okay. Now we came to know that the system shall be available to deliver the insulin when required. These are the few more requirements which we observed. The system shall perform reliably and deliver the correct amount of insulin to counteract the current level of blood sugar. Okay, so depending on the blood sugar levels, okay, insulin must be provided, and the system should work reliably and deliver the correct amount of insulin. The system must therefore be designed and implemented to ensure that the system always meets these requirements. So these are few more user requirements. Okay, these four and these three. What are these? These are the user requirements. In order to satisfy these user requirements, what you are going to do, how you are going to make these requirements come true, that is known as system requirement. All right. Okay. Now we will move towards the second case study. The second case study is a patient information system for mental health care. It is also called as MHC PMS. It is a very famous software which is being utilized by so many hospitals. Okay, so that is also called as mental health care and patient management system. Okay, yeah. So I will just give you briefing of this software. Okay, so in this software, you can see that this is the architecture. Okay, this is the architecture of mental health care patient management software. You can see that 1, 2, and 3. What are these? These are the 3 different clinics. Okay, clinics is nothing but the hospitals. There are 3 different. I'm just taking 3 hospitals. There can be n number of hospitals. Okay, which are connected to this patient healthcare management server. There is one server, and all these hospitals are accessing the data and also sending the data to the server. So this server plays very major role. From this, the data, okay, can be utilized, or the data can be stored, updated. Everything can be done through these 3 medical clinics, or you can say hospitals, right? Then we have a database. So this is the database which is storing the information of patient. All right. So here, so there is one database which is being shared by all these 3 clinics. So hence this database is called as a distributed database. Okay, distributed database. What is distributed database? Anybody knows that? What is distributed database? Anybody know? Anybody know what is distributed database? Nobody? Yes, what is distributed database? You know at least what is database, isn't it? So here, why it is called as distributed? Because this database is made available to n number of clinics through internet or through network. Not only internet, but also through network, right? So there are different types of networks like LAN, which is called as a local area network, MAN, metropolitan area network, WAN, that is wide area network, and PAN, which is private area network. So there are different types of networks. All right, yes. So here we are using one database concept which is distributed throughout the network. It means this patient database is made available to all the clinics anytime and anywhere through the internet or through network, right? So that is called as what? Distributed database. So this is our architecture, right? So here we can see that there are 3 clinics, 1, 2, and 3. So now, what is the responsibility of these clinics? Okay, what is the responsibility of these clinics, right? So let us see that. Yeah, so let me tell you in detail now. See, a patient information system, it is used to support mental health care, right? Which maintains information about patients suffering from mental health problems and the treatments that they have received. So this is the software, okay? So this is the software. Just 2 minutes, guys. Okay, sorry for the inconvenience. Yes, so where I was, so it will tell us that there is a patient information system, okay, and this system is going to maintain the records of the patient, those who are having the mental sickness, okay. So this is a software only for the mental sickness, people, those who have a stress problem or mental stress problems, right? So next, for these people, okay, so those who are having mental sickness, they cannot go to normal doctors. They have to go to some psychiatrist, or they have to go to some specialized type of doctors, those who will provide meditation, or those who will provide another types of medicine for mental relaxations, right? So there are different doctors, those who will provide these kinds of treatment to the patient. All right. Now, so every time, if that is the case, that only we need specific type of doctor to provide mental care for the patients. Okay. So if in case of emergency, the patient will have some problem and he will go to the regular center. Okay. If it is not possible for him to go to his specific doctor, and therefore he will go to other clinic, okay, which is of the same brand. For example, let us take an example of KLE clinics, right? So KLE is a big hospital, right? It has a huge infrastructure. So they have different buildings. So let us consider that in a different building, they are implementing this software. This software is implemented in separate building, right? So there are the 3 different clinics here. So let us consider that this software, okay, is being used. Suppose this is used in building 1 of KLE. Suppose this is used in building 2 of KLE. And suppose this is used in, not in Belagavi, suppose in any another city like Dharwad, right? So, and the patient is located at some other place. So now, suppose the patient is pursuing treatment at this hospital, which is there in, suppose, Belagavi, and we have this in, suppose, the second building itself, and this is in Dharwad. So now the patient is taking a treatment in this hospital, but at present it is not possible for the patient to go to this clinic. So what that patient will do, that patient, okay, what he will do, he will receive, okay, he will go to this clinic which is located in Dharwad. Now the doctors present here in Dharwad, okay, are able to provide treatment for this patient who is from Belgaum. Why? Because the doctor, okay, who used to provide him the treatment in Belgavi has recorded all his details in the server. Okay, through server, all his details are updated into the patient database. So every detail about the patient, like what kind of treatment is given to the patient, or which medicine is given to the patient, how many times the patient has to take the medicine, what is the dosage, all these things, okay, all these things, right, are highlighted there. All these things are highlighted. Hence, the doctor who is located at Dharwad, what he will do, he will access this server, and with the help of server, he can access the patient database, and it becomes easy for this doctor to provide treatment for this patient, okay, to provide treatment for this patient. Hence, it becomes easy for doctor to provide treatment for this patient by accessing the information from this database. Yeah, are you getting it? So this is why these kind of healthcare softwares are called as distributed softwares. It means changes can be made from anywhere. Changes can be made from anywhere, and the data can be accessed from anywhere at any time. All right. Okay. Yeah. So that is the description. It is an information system that is intended for use in the clinics. So every clinic is going to use that software. And one more thing I want to tell you. Okay. Suppose this is the first clinic, this is the second clinic, and this is the third clinic. So they can, this three clinics, okay, can access the data of any another clinics. So right now we can see that there are three clinics, 1, 2, and 3. So clinic number 3, which is in Dharwad, can access the data of clinic number 2 as well as clinic number 1. Similarly, clinic number 1 can access the data of clinic number 2 and 3, and vice versa. Why? Because they are centralized. Their data is centralized. Okay, why it is possible? Because their data is centralized. All their data is saved inside the common server. Okay, and they are using a common database which is called as a patient database. So this database, okay, once when all these clinics have got access to this database, they can exchange any of the data. Is it clear? Yes. And not only that it is the responsibility of each clinic to go through server, but they have to also maintain their local database. They have to also maintain their local database. Okay, they have to also maintain their local database. So they have to keep on updating their data locally on their computer, and at the end of the day they may update this data through the server into the patient database, or they may update it simultaneously, but the local copy of the database is also mentioned in their own computer. So it is possible to access the computer locally as well as remotely. Remotely means, accessing remotely means what? Accessing another computer through another server. Okay. So this each of these clinics are also maintaining their data locally, as well as they are also updating their data into the database. This is how this mental health care software is going to work. All right. Okay. So it makes use of centralized database of patient information, but has also been designed to run on the PC. As I told you, it is centralized, as well as they have to maintain the data records on their own computer also, so that it can be accessed on the local computer also, as well as they can also export and import the data to and from other computers which are connected to this server. Okay. See, when the local systems have secure network access, they use patient information in a database, but they can download and use local copies of patient records when they are disconnected also. It means, as the data of the patient who is receiving clinic number 1 is also available locally, as well as the data is also available in the server. So that patient's data can be also accessed locally as well as it can be accessed from the main server. Right? Okay. So the servers that are needed for these kind of systems, okay, the servers which are needed for these kind of systems are like you can say it must be very very secure and must be updated all the time. Okay, so this system will help the medical staff to generate okay timely information and treatment for the patient. So you can generate the information every second as it is updated, okay, and proper treatment can be given to the patient. So best example for nowadays due to COVID, you can see that lot of apps have been generated. Through these apps, you can see that so many doctors are providing the online prescriptions or they are also providing online treatment. How it is made possible? Because they have the database of the or they have records of their patients. So suppose I am a patient and suppose I have some issues like somewhat like I have a headache problem, suppose migraine problem, and every month my doctor is providing me some medicines, and due to COVID it is not made possible for me to go to my doc. Okay, so what my doc will do is my doc will see my data. Okay, my doctor will see my data, and depending on that data, the doctor will give me the prescription. Isn't it? All right, are you getting that? So this is how the mental healthcare software is going to work. Yeah, so these are the basic key features. Okay, so individual care management. Now, these are nothing but what you can say that these are the different modules of the software. Key features are nothing but the different modules. Okay, so key features are nothing but the different modules of our software. So we have modules. Okay, so just I will just highlight those. Okay, so we have modules. So what are those modules? Individual care management. So what this individual care management is going to do? They will maintain the records of patient. They can edit the information or view the history of the. So this individual care management, what it is going to do? Individual care management, it is all about the patient management. Okay, yeah, it is all about what? Patient, right? It is all about patient, right? So individual care management, it is all about patient management. It is going to take care about your patient, right? So patient management in the sense what it is going to do? Adding the records of patients, editing and viewing the details of the patient. Okay, now, this is not about providing treatment. It is only management, providing the management for the patient. Next is patient monitoring. So what is patient monitoring going to do here? The system monitors the records of patients that are involved in treatment and issue warning if possible problems are detected. So the name itself indicates monitoring in the sense what? Monitoring is all about taking care of a patient. Okay. So how do you take care of a patient? By checking out what type of treatment is given to the patients, and in case of ICU, if the patient is under ICU during some emergencies, so the software has to give any alarm, okay, or the software has to highlight that suppose in ward number 10 the patient is serious. So all these kinds of things are carried out through patient monitoring system. So next component will be administrative reporting. So what is administrative? Administrative is nothing but coming to the main working area behind the scene. Okay. So what is that? See, a report showing the number of patients treated at each clinic, the number of patients who have entered and left the care system. Okay, care system is nothing but ICU. Number of patients sectioned, so in different wards. What are the drugs prescribed and their cost? So everything, how they are going to run an hospital, how they are going to maintain the cost of hospital, like nurses, the drugs, okay, light bills, or maybe any ambulance bills, or how many patients were discharged, everything that comes under administrative reporting. All right. Next, privacy is all about what? Maintaining the information privately. You cannot share the information of any patient who is being admitted in the hospital without the consent of a patient. Suppose now every day you can see that lot of COVID patients are getting admitted in the private hospitals. Okay, but uh, what I can say is uh, the doctors are not going to provide you any personal information. They will never, they are not allowed to share the personal information of the patient, right? Safety, see, some mental illness cause patients to become suicidal or danger to other people. Wherever possible, the system should warn medical staff about potentially suicidal or dangerous patients. So what does it mean? Safety measures must also be given by your software. Suppose the patient is very sick and he may try to attempt suicide also. So this mental health care software must be managed very critically. So creating a job or creating a software job for mental health care is very challenging thing, because you have to monitor the patient and every activity of the patient at every second. All right. Okay. So those are the safety measures, right? Along with that, uh, you should also monitor the instruments, power, communication hardware, and report faults to the management system. You should also manage the environment factors, like you need the battery backups. You should also take care of battery backups, cleaning the wards, all these things, right? Then if any report failed, updating the report, all these things. So this is all about what a mental healthcare patient management system. So it is nothing but about what a total hospital management, you can say. Okay, so I have taken example of only sick, mentally sick people, but this is overall an example of patients in managing a hospital, right? Hospital management system. So these are all the requirements. So depending on these are our set, these are our data set, all these are our modules. Now the challenging thing is how you are going to write code for these modules. The challenging thing is how you are going to write the code for these modules. All right. Now I will show you one more example here. Right? Depending on that mental health care software, depending on that, we will see an example of user requirements, and we will also see example of system requirement. Okay, see here one small example. This is a user requirement of a mental health care software system. So MHC PMS shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. So what our software has to do, what user is providing, what user is telling us, user is telling me that you have to generate monthly report. Okay, user is telling me that you have to generate a monthly report, and in that report you have to show the cost of drugs. Okay, so we have 3 clinics. Okay, right now we have 3 clinics in our server. So you have to provide the monthly management report of cost of drugs prescribed by each clinic during that month. It means, in short, you have to calculate what? You have to calculate the number of drugs and cost. Drugs are nothing but medicine. Okay. So you have to calculate the cost of medicine that is being provided for all the 3 clinics, right? Now, for that, what you are going to do, that is called as system requirement specification. In order to get this requirement done, in order to get this activity done, what all things are needed? Okay, suppose this is our problem statement and this is the algorithm to solve this problem. This is the algorithm. After this, you are going to write a flow chart, just like activity diagram. And after drawing the flow chart, you are going to write the code. And then finally, our task is successful. So this is the problem given to us. This is the user requirement, which is nothing but the problem statement. And this is the algorithm to solve this problem statement. Okay, so user requirements are nothing but the requirements given by user. System requirements are the more structured explanation to satisfy this requirement. Okay, now to satisfy this requirement, what you're going to do? See guys, I have a time of only 3 minutes. So in these 3 minutes, I will explain this. If the session gets discontinued, we will be taking it in the next session, right? So I will try to cover this. See, what about your system requirements, right? Let me tell you that. See, on the last working day of each month, what you're going to do, a summary of the drugs, their cost and clinics shall be generated. At every month end, what the person who is handling this software, he will update the details, okay, that how many medicines are prescribed and their cost. Then automatically the report is generated at 5:30. Okay, at the month end, last working day of the month, automatically the report is generated, right? So that report will give you a list of drug, the total number of prescription, the number of dose, and the total cost. So that format of that list, okay, whatever format is generated, that will have date-wise medicines provided to the patient, and also the dosages, how much amount of dosage is provided, and also the cost, right? See now, if drugs are available in different units like 10 mg, 20 mg, separate reports shall also be generated. Once when you generate the report, okay, once when the data is updated, you can sort the data according to date, or according to the different drugs company, or according to the dosage also. All these things you can do, right? And then finally access the cost, right? So this is limited only to the hospital. This is very confidential report. All right. So in order to generate this, in order to satisfy this user requirements, okay, you are going to frame these kind of system requirements. So in short, what I can tell you, user requirements are the problem statements that are to be solved, and system requirements are nothing but set of activities that you do to solve the user requirements. All right. If any queries are there, you can ask. So in tomorrow's section, we will go to functional and non-functional requirements.
कचरे वाली गाड़ी में जब कचरा डालो
Mute,
सबको
please.
की गाड़ी
Mute your mic. Yeah, if any queries are there, you can ask.